Welcome to HashMap. Store key-value pairs efficiently. Here is what we will learn. Let's get started. Why do we need this concept? Searching through lists, item by item, is slow for large data sets. How to find data in one step? Slow sequential search. Wastes time and resources, hard to scale efficiently. HashMap finds data instantly using unique keys. How is HashMap used in the real world? User authentication. Store session tokens and user data. Word frequency counter. Count occurrences of words in text. Shopping cart. Track items and quantities efficiently. HashMap powers all these applications. Let's see the problem it solves. So what happens without HashMap? Storing key-value pairs in parallel arrays. Look at how messy the code gets. Manual synchronization needed. Slow ON key lookup. Error-prone maintenance. There has to be a better way. Here comes the solution. HashMap. Look how clean the code is now. O1. Lookup time. No duplicate keys. Fast key-value access. Compare the difference. And that is why we use HashMap. Let's see how to implement HashMap in code. Here is the implementation. Create HashMap. Initialize empty key-value map. Add entry. Store USA with capital. Add entry. Store France with capital. Get value. Retrieve France's capital. Print result. Display retrieved value. Now let's see the output of this code. Quiz time. Test your understanding. What does HashMap store? Which one is correct? The correct answer is HashMap stores data as key-value pairs. What's the output? Which one is correct? The correct answer is get A returns value 1 associated with key A. What happens with duplicate keys? Which one is correct? The correct answer is duplicate keys replace previous value with new one. What's printed? Which one is correct? The correct answer is after removing key 1, only key 2 remains. Here is a challenge for you. What's the output? Comment your answer below. If you found this helpful, please like and subscribe.